Okay, this is my fourth shot at this video. Luckily, I've only gotten through a few seconds of each one of them, but let's try this again. So Unit 7, Topic 2, Day 4, Theoretical and Experimental Probability. We're talking about permutations and combinations here. So if you look at the top of your page, it gives you the idea of permutations and combinations that we talked about at the end of the lesson yesterday. And it gives you 4 problems. See if you can try those formulas and fill those formulas in just based on what you see, and see what you get as an answer, and then check back here and see if we have the same thing. So if you see this 10p6, this 10 is in the place of the n, the p stands for permutation, and the 6 is in the place of the k. This is essentially that we have 10 items, and we're choosing 6 of those items. Okay, so to follow the formula on top, it's n explanation, so it's the 10 explanation over on the bottom, the n minus the k, so it's going to be 10 minus 6 factorial. That's what my explanation point is. So this simplifies to 10 factorial over 4 factorial. And what that is, the factorial sign means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So factorial is multiplied by every integer all the way down to 1. And then this one is then 4 times 3 times 2 times 1. And so the interesting thing here with how multiplication and division works is we can get rid of our 4, 3, 2, and 1 since they're on top and bottom. And that leaves us here with the problem of 10 times 9 times 8 times 7 times 6 times 5. Okay. Now, interestingly enough, how would we have done this before? Imagine this was, I have 10 jelly beans and I want to choose 6 of them in a specific order, not in a cup, but in a specific order. Okay, so we would have done, I have 6 different ones I want to choose. How many do I have to choose here? I had 10. Once I've chosen that one, I now have 9. I now have 8, 7, 6, 5. And that and this are exactly the same thing. So answer for this one should have been 151,000. 200. That's how a permutation works. You can do the same thing on this one. So that's going to be 15 factorial, n factorial over n minus k factorial. So 15 minus 13 is 2 factorial. Okay. In this one, you could write it out, but it's 15 times 14 times, and it's going to keep going down until you get times 3 times 2 times 1. And then on the bottom, you just have 2 times 1. So the only ones that cancel are these here. And this one is going to come out to 653,837,100 or 837,184,000 and that. Okay, so it's very, very, very large. Okay, based on how you're doing that. Now, if you look at these combination ones, the difference here between this and the permutation one is take the permutation number and then divide by the ones that repeat each other. Okay, so the way the formula works is n factorial over n minus k factorial, the exact same as what we have here. Okay, so that would essentially come out to that 151,200, and then you would divide it by your k factorial, okay, or however many of those options there are. This is the way it looks, so you can go into the logistics of it, but this is the way that it looks. And then if you do that, 10 times 9 times 8 times 7 times, you can 6, 5, 4, 3, 2, 1, but these two cancel out here, and then you have this 4 factorial. Well, if you're simplifying, now we have, let's just get rid of the 6 factorials. You have 10 times 9 times 8 times 7 on the bottom, 4 times 3 times 2 times 1. Okay, 4 times 2 is 8, so those can cancel each other out. Okay, a 9 and a 3 can simplify, and this changes to a 3. Okay, so now we have 10 times 3 times 7, and that gives us an answer of 210 that we should have gotten here. And then last but not least, if we do the same thing with the other option, the really interesting thing that happens here is when the permutation is not so big, the combination's decent sized. When the permutation is huge, the combination actually tends to be smaller. Okay, so just an interesting thing. But again, n factorial, n minus k factorial, and k factorial, and simplifying those out, what does it simplify down to is 105. Now, we do not expect you to be able to do this all the time. Your calculator will do this for you. So the next thing that I suggest you do is use your calculator. Oops, sorry, shouldn't have done that. To figure out how to do this. So if you get your calculator out, and you're in a computation page, I'm going to move it over here so we can see our problems. Okay, and I want to type in 10p6. You're going to go to menu. You're going to go to probability, and you're going to see permutation and combination right there. So this one happens to be a permutation, so I'm going to do that. You're going to see it says NPR. So our NPK is the same thing as NPR, just a different variable they're using. And what you have to do here is you have to type in 10, comma 6. Your comma's down by your letters, and then 6, and hit enter. and you're going to get that same number that we got there. If you want to do a combination, same thing, menu, probability, combination. Let's say I do number 3 here. So I still do 10, comma 6. I hit enter and it's going to give me the 210. So we looked through this idea right here just so you have a general idea of what the formula is, but we are going to be doing these problems by calculator. Okay, so don't worry too much if you didn't quite get that. When we determine probabilities of events for situations in which the outcome and the sample space are equally likely, it helps to be able to count the number of outcomes both in the sample space and in the event. In order to do this, we must think about certain aspects of the event. So one of the questions is, does order matter? Okay, so when you look at this, you're looking at a combination versus a permutation. And do previous outcomes affect future outcomes? So are you doing something that was like the 52 times 52 times 52, like that? Or are you doing something that was the 52 times 51 times 50, and so on and so forth? This essentially leads to a permutation, okay? And this right here, you have to go back to the fundamental counting principle. Okay, so we do have to use that fundamental counting principle once in a while. But ask yourself those two questions, and that'll help you determine what you're doing. So what I want you to do now is complete your worksheet. When you are done, check your answers on the homework answer sheet or check them as you go. But you have all of the questions 1 through 5 to get through, and then you are done for this week. Good luck.